What is the impact of AI on startups and organizations in general? You're watching Microsoft Startup AI School, a Microsoft Reactor series of exciting and informative sessions where we introduce you to the basics of Gen AI and show how you can use AI to enhance your creativity, productivity, and efficiency. Hi everyone, I'm Suzanne, a program manager with Microsoft Reactor and your host for Microsoft Startup AI School series. And today we are actually at our final episode of our first season. Okay, that's quite weak, but okay, yeah. So before we continue, I would love to know your journey with us. Tell us how many episodes out of 10 we have watched, or if you're new today with us, let us know. So we started our journey way back in March, and we planned this really hard, making sure that we had a good mix of panel sessions, starting from an overview of the latest AI tools and trends to technical topics like accelerating app creation with low-code AI and Copilot, and upping your data analytics game with Microsoft Fabric and Copilot. And midway, we injected some inspiring panel with some of our startups to keep you going. And we spoke about developing with GitHub Copilot, LLM, responsible AI. And here we are today, finally at our last episode. And we want to help you get AI certified. So today's topic is all about AI-900 certification prep. At any time of the session, I also encourage you to drop into our comments and tell us what you would like to see or learn so that we can create content that's worthy for you and know what you want to truly learn. So enough of my voice. I'm going to quickly invite and trainer for today. Let's have Sub join us. Hello.
Hey, hi Suzanne. Thank you very much for having me on the event. On the call.
Yep, great to have you on the show today, and thank you for being here. Why don't you quickly introduce yourself?
My name is Abjit Gill. I've been a Microsoft certified trainer since 1998 and been in IT for 35 years. Been working for some of the largest organizations around the world, and now I run a consulting company out of Singapore. I work with companies like NetAssist to do training, and I run consulting in the Asia Pacific region.
Right, great credentials. And so, as usual, I'll love to learn the fun and casual side of my speakers too. So 5 quick questions, this or that questions generally. Shall we?
Okay.
Saturday or Sunday?
Saturday.
Bad haircut or bad hair dye job?
Oh, bad hair. Never cut my hair. It never died. Okay, so none.
Okay, so not very relevant.
Yeah.
Okay, voice chat or text chat?
Voice.
Right, okay. And then toilet paper over or under?
Ooh.
Yeah. I bet your colleagues don't know about this one.
I had no idea what that is. I think under should be better.
Okay, basically how you use your toilet paper at home. Is it like the over or the under?
Over is better.
Okay, and last one, superhero or supervillain?
Oh, supervillain, of course.
Nice.
They have more fun.
That's true, and very brave of you to admit that. Yeah. Okay, so before we start, I'm just going to draw everybody's attention to our code of conduct. So basically, for everyone to be respectful in your comments and have a great time. So please feel very free to ask questions in the chat, and we'll try to answer during Q&A. So, okay, over to you, Sab.
Okay, thank you very much. And let's get started. So this is I'm sharing my presentation now. And what we're going to do is we're going to walk through a series of questions which are related to the exam prep for AI-900, which is Microsoft's certification for Azure AI Fundamentals. Right? So feel free to ask questions as I progress to the series of questions. All right. So now when you do the AI-900 exam, what you're going to get is the coverage of the exam will consider a couple of different sections. Number one would be the AI workloads and considerations. So what are the different kind of AI workloads you can have in Microsoft Azure, as well as Microsoft OpenAI on Azure? Well, we'll take a look at that. So there will be a series of questions of understanding at a high level what AI workloads you have and how do you map them for specific use cases. Then we'll take a look at principles of machine learning on Azure. So this will be on the perspective of using machine learning to create your own models, evaluating the model, deploying the model, and then operationally that putting them into a cycle of getting new data and updating those models, right? So of course, in this case, you wouldn't have to know the details of how the process looks like, but you would know where you would need to get this done. Then we'll take a look at one of my Azure AI's services that's called computer vision. So we'll take a look at what kind of workloads you have for computer vision. And that again will give you you'll need to know some high level details of what kind of workloads is usable. So one scenario would be things like face API, the other one would be vision, image analysis, and of course extraction of text, which is within the vision. That's the OCR functionality of computer vision. Then we'll go on to take a look at another Azure AI service known as natural language processing. You will need to know what the workloads are for those. So this is where we take a look at natural language usage and understanding and converting that to an action item. All right. So for example, you could say things like switch on the light, and then that goes into a natural language processing model, which understands the intent of that sentence. And then of course, you will then write an application which will receive the intent and then take action on switching off the light, for example. Then the last part, of course, generative AI. So you have OpenAI on Azure. So there will be a workloads understanding of OpenAI on Azure and how do you use those, right? So there's very clear separation between Azure AI services and Azure OpenAI services. You would need to know what those are. So what I'm going to do is for the next, I would say in the next 35 minutes or 45 minutes, a walkthrough series of questions with you. We're going to be very interactive. I'll show you the question. We'll discuss about it. And if you want to give it a try at the start of answering the question, go ahead, put that in the chat, and that'd be awesome. Okay. So let's get started. So I'm just going to go ahead and move on to my first question. Now, before we go there, the exam usually takes about 45 minutes. Pretty short question. And you can see that's actually the URL, which points you to the certification for Azure AI. And in that URL, you'll be able to see information with regards to all the modules that you can do self-learning, or you can use that as an instructor-led training. And of course, there's a quick assessment question there as well. Okay, so let's jump right in and see how ready you are for a AI-900 certification. Remember, this is a fundamentals exam. So it means it's more of understanding the usage and functionality of services within Azure rather than knowing step by step how to implement or design it, right? So let's go into the first option. Here we go. Okay. Now, what we're going to do is we're going to match. The question wants you to match AI workloads to appropriate scenarios, right? So for example, in this is one type of question that you're going to have where you will need to drag items on the left under workload types and then drop them into the answer area, depending on which one we are referencing. So the first one is about anomaly detection. All right. Anomaly detection means you would have a bunch of data, could be log files, could be transactions that are occurring. We want to find a baseline. We want to see anything that's above or below that baseline. So that will be anomaly. Okay. Second one would be computer vision. You notice this computer vision means that is a use of image, looking at a computer image or looking at a video and understanding the content of that. Then you have machine learning. This uses the regression algorithms. And then finally, of course, you have natural language processing. Let's take a look at anomaly. Now, with anomaly, you'll notice that what we want to do is we most probably want to take a look at a sudden reoccurrence of a transaction, and we want to be able to identify if any one of that transactions are not normal or abnormal, right? So in my case here, the answer would be to identify a fraudulent payment. So you're going to receive a lot of payment, and what you're going to do is you're going to take a look at all of them payment and see whether any one of them eventually is different from all the others. So obtaining a baseline and then comparing this with the baseline. Number two will be computer vision. Now you notice in computer vision, we're going to take a look at a content. In this case would be workload. You notice this is handwritten letter. In a handwritten letter, most probably you have a photo of the handwritten letter. So which means using OCR capabilities of computer vision, we'll get to identify and understand handwritten notes. Could be a banner, could be a number plate of a car, could be a road sign, could also be handwritten letters. Number three, machine learning. So in machine learning, what you're going to do is you're going to literally go from having raw data to preparing the data, using the data for training a model, and then validating the accuracy of the model, and then eventually deploying the model if the accuracy and measurement shows that the model is usable in a production environment. All right. So in this case, you'll notice that what I'll need to do is to take a look at data and then use that data to predict a certain amount of outcome. So in this case, that will be toy sales, right? So we have toy sales data, and we're going to predict what would possibly be the sales looks like in the coming months or coming year. Now, finally, one more would be to understand words which are being said, and we want to understand whether it's a positive or negative word. So you can see here that is going to happen from the natural processing. So natural processing literally can take input of text and do a couple of things. Example, summarize the text, identify whether it's a negative or positive or neutral sentiment, and so on and so forth. Okay, so this gives you a typical option of what the answers are going to look like. Now, so again, you can see that the goal is to understand what each one of those AI services and what kind of workloads they would be used for. You notice you don't need to know you don't need to know the details of how anomaly detection is deployed, configured, enabled, and so on and so forth, right? It's just about knowing which service workload maps to what kind of scenario, all right? Hopefully that was a really good. Next one, let's jump to question number 2. In question number 2, the question says that we're running a charity event that involving posting photos of people wearing sunglasses on Twitter, right? You need to ensure that you only retweet photos that meet these 2 requirements. So which means, number 1, you must include one or more face, like the one that you see on my slide right now. That's a person who you can see the face. Number 2, they must have at least if you have more than 2 faces, all right, one of them should be wearing glasses. If you have just one, and then that one person should be wearing glasses. So what we need to do is we need to take a look at a service which can recognize a face. Not only that, attributes of the face. In this case, a mask, sunglasses, and so on and so forth. So what should you use to analyze the image? Okay. It says to meet these 2 requirements. You notice computer vision, most probably, it's not a wrong answer, but a better answer would be to say that we're going to verify, okay, an operation in face service or detect operation in face service. Okay, because you're not trying to verify a person's identity or recognize who the person is, what you most probably will be doing is detect. You're going to detect that a face exists in a photo and the face is wearing glasses. All right, so that is the detect option. All right, so just take note, it can go to this level of detail with the question. In this case, knowing what the difference between verify and a detect means. So verify literally means verifying the face belongs to a specific identity or it's recognized as a specific person. In our case, all we want to do is the detect part of it. Okay. Next, go on to question number 3. And in question number 3, what we're going to do is, let me see, here we are. Oops, sorry, here you go. All right. Now, remember I said that one of the things that you do is, one of the things that you do with machine learning, creating machine learning models or training machine learning models is to eventually create to have a certain kind of measurements to see whether that machine learning model that you created is accurate enough, is doing its job. All right. So we want to be able to understand which metric can be used. All these are different metrics. You have true positive rate, you have mean absolute error, you have coefficient detection, and then you also have root mean square error, correct? So let's take a look at some of this. So for example, the true positive rate, or called TPR, correct? Also called sensitivity, is calculated based on a certain functionality of your model, right? So we measure that using TP plus FN, which just shows you the rate of accurate predictability of the model, correct? So TPR is the probability that the actual positive will test positive. Example, if it's a negative, the model will tell you it's a negative. If it's a positive, it will tell you a negative, correct? So we're trying to see the positive, negative, and negative, negative, or positive, positive. So this literally means that you could measure the accuracy of the model, right? So the outcome usually is, I think the outcome is called a heat chart. And this is what we want to do. And then you also have mean absolute error. Mean absolute error, so one of the things that you're going to do is you're going to be able to search for this data on Bing, and you'll be able to take a look at what each one of that means. All right. So the mean absolute error basically is a measurement of an average variance between the data set values, which you use for prediction to test, and the actual value that is predicted by the model. So you can see this is also an example of predictability of the accuracy of the model. You also have one more called the coefficient of determination. It's called R2. I think that's a code for the formula, right? It's actually a number between 0 to 1 that measure how well statistically a model predicts an outcome. And then the last one would be to say the root mean square error, RMSE. And RMSE basically is to indicate, it's actually a square deviation or root mean square error deviation to kind of these two are kind of related, right? It's usually used to measure the difference of the true results and whether the predicted results. Okay. Now, so you can see at the moment we are working with a classification model. A classification means either it's 1 or 0 or yes or no. Okay, and then of course you have models which will be related to measuring a value, for example, correct? Or give me a value that I most probably what kind of sales numbers I'm going to have later on, correct? So what kind of sales I'm going to have in the future. Okay, so what do we need to do? So what we need to do is when we're working with classification, we want to measure things like accuracy, we want to measure precision, and we want to measure something called a recall. These are all different ways of we can do it. So most probably the best way to do that will be to work with the true positive rate. True positive rate will give you a best option to identify those 3 points if you need to. Okay, right? So accuracy, precision, and recall are good ways to do that. And one way to do that, we look at things like the true positive rate. Okay, so this gets a little bit more complicated, but if you take a look at the link that's provided at the beginning, which is the Microsoft Learning Path for certification for AI-900, so all 4 of these are explained. The keyword here is when you look at a question in the exam, try to find what is the keyword in this question. The keyword here is this. It's a classification model. So it's not just about evaluating any AI model, it's a classification model, right? With classification model, we don't need to compare the value because the classification model is just I go either yes, no, 1, 0, true, false. So we can easily do that with true positive rate, okay? If it's a non-classification model, the outcome will be a value. Like, for example, it would say, well, you're going to get a sales of 20,000 next month. But then you can compare to a measurement that testing data, and you can see whether you really had that number. So it's not just a true yes, no kind of a scenario. All right. So the keyword here is classification. Let's go take a look at another one. All right. So which is calculated? It's calculated the probability of correct image classification. What is used? Again, this is now we're going to talk about image classification, right? So how to calculate the probability? Calculate the probability of a correct image classification. You see, this is different now. Now you have an image. If I gave you 60,000, 100,000 images, and I told you, hey, could you classify these images into different categories? So how would you do it, right? So this becomes pretty interesting because now it's no longer a 1 and 0, but it's more on a classification with regards to an image being defined, right? So the answer in this case with image, there's nothing else you can do. There's no numbers, there's no yes, no. All you can do is look at accuracy, all right? Accuracy is the calculated probability of a correct image classification. This is how you measure it. So you would see the image yourself and you know that what the outcome of an image classification by the AI vision service will look like. Okay. Let's see. In some scenario, I think sometimes the you will see a question being measured at a what do you call this, confidence. But notice the confidence part could also be an answer in this case as well. All right. So when you score a classification, when you store a classification model, right, you use something called confusion matrix, which actually uses accuracy, recall, and precision. All right. And there's also used things like the AUC. So therefore, the based on the answer, accuracy is the one. So you'll see people saying confidence could be one, but we don't do that measurement with image classification. That's why the reason accuracy should be the answer. Okay. Let's go on with the next one, number 5. Now, when we use Azure machine learning is used to when you want to go from end to end, you want to create or manage an end-to-end cycle, which means you have raw data, you're going to transform the data, you're going to do some sort of feature engineering to the data, and then you want to pass on the data to a algorithm, a machine learning algorithm. You might pass some parameters to the machine learning algorithm as well, and then you're going to generate a model. You might repeat this process multiple times, known as experiments, until you get the most optimal model. Okay, so that's what Azure machine learning is. So you use Azure Machine Learning Designer to publish an inference pipeline. What's an inference? Inference means you're going to give data and you're going to get the answers, right? So inference means to basically use that model and predict. Now, which 2 parameters should you use to access a web service? Now, if it's a web service running on Azure, which means it's on the internet, means access is done by using HTTP as a protocol, application protocol layer. To connect to it, you will need one thing. Number 1, the URI for where that service is. That's number 1. Number 2, you also will need the authentication key. The authentication key. So of course you're going to connect to the endpoint, which is a URI. And to authenticate to that URL, you will need a authentication key. So the 2 things that you will need in this case is the REST endpoint, means an API endpoint for HTTP. And number 2, you will need the authentication key. All right. Notice it says inference. So the keyword here is actually inference. The reason I say the keyword, because if you look here, we are trying to, oops, sorry, let me go back here again. I'm trying to get my pen out. Here you are. So this is the keyword, inference. Inference means it's no longer training. You've already done the training. You are trying to send in some real data and you're trying to have a prediction generated. That's inference. So we definitely cannot use the training. All right. Model name is part of the URL. So you need this endpoint where it includes the model name. All right. And of course, the authentication key, definitely if you're going to connect to an endpoint, you will need to be authenticated. All right. That's the question I have. Let's see if we have anything in the chat I need to take a look at. Well, not at the moment. Okay, let's go in and take a look at. Let's go and take a look at the next question. Okay, here we go. Let me just move on to the question number 6. Here you are. Okay. Now, again, you're building a machine learning model. You're building means you're not using one of those pre-created models. You are building one for yourself from scratch, all right? By starting with the data. And you're using the automated machine learning interface. What is automated? Well, one way is you do the whole process end-to-end manually. You select the data, you work on the data, create the data set, and then you feed that through a model bit by bit. You might use a GUI code for designer You might also write Python code in a notebook, but you can also use something called auto ML. Auto ML means you're going to provide the data set, you're going to give a choice of algorithms that you want to use, even let the auto ML decide on feature engineering of your data, and it will then run a couple of experiments and give you a couple of couple of outputs, couple of models, and you're going to be able to, it'll tell you which is the best model so far. All right. Now, you need to ensure that the model meets the Microsoft transparency principle for responsible AI. Now, transparency in a responsible AI means that you should be able to you should be able to explain, or you should be able to show on how the AI model made the decision, or the machine learning model came up with a prediction. So let's take an example of a bank loan. So to get a bank loan, let's say you submitted all your information and an AI model decides whether you get the loan or not. Now, the things that you have, the information that you have to submit would be things like your age, you have a job, what's your salary like, do you live with your parents, or do you have your own place? If you have your own place, did you buy it, did you rent it, and your age, and also maybe where do you live in the city, and maybe even your ethnicity background. Okay, so you provided all these details. Now, the model will use all these details and come up with an answer whether you should get the loan or not, recommends whether you should get a loan or not. And usually that means whether you can pay back the loan. That's a big concern for the bank, for example. Now, what if the model made a choice a big part of the decision of the model was based on which part of the city you lived? Excuse me. So that wouldn't be fair. What you just because I live in a certain part of the city, so you mean what I can't afford it, or maybe if I'm from a certain ethnicity background, so you mean because of that I'm not. So why is the model looking at those things? What the model should be looking at is things like my salary, or whether do I own an apartment or a house, and maybe to some extent the age, because we can technically say people who are younger most probably don't have that kind of money, majority of us, and of course that could be one too. So when you have a transparency, you are following the transparency principle, you are actually explaining how the model came up with the answer. And it should be using fields which does not indicate any bias towards skin color or age or where you live and stuff like that. Correct? Okay. So the way you do that is you need to be able to do something called explain. You need to enable explain best model. So the top model that came up, the automated Azure machine learning, you must have something called enable explain. Enable explain will give you a couple of graphs. Will show you exactly out of all the data that you provided, which was the most significant for the model to come up with the decision of whether you get a loan or you don't. Based on that, you get to know whether there is inclusiveness or bias or not, inclusive or not, or if there's bias or not within your AI model. Okay, so we call the answer would be enable explain best model. All right. Let's go on with the next part, question 7. So in question 7, for machine learning progress, how should you split? Now, when you are training a model, you're going to have two things. You're going to have a data set. Now, we're going to take this data set, give it to a machine learning algorithm, which is going to find a relationship within the data and be able to come up with a model. The model in a machine learning model or AI model is nothing more than just a piece of software, right? Which is generated by the machine learning algorithm. It generates that piece of software. That software is called a machine learning model. Now, once you have generated it, how do you test it? Well, you need to test it with the data that you have an answer for. You have an answer for that data, correct? So, for example, let's say if I have patient data, and I know what the patient's health problem is, and I give it to the machine learning model. It generates a model. And now what I can do is I can test the model because I know what the patient's medical issues was. So I can take another patient data where I know what the actual patient issue, medical issue is, and I'll give only the portion of the patient data to the model and see whether it comes up with an answer. And I will compare that with the answer that I already know. So that's what we're going to do, right? So what we're going to do is we need to split the data for sure, right? So that's where the training and the evaluation. So use features for training and labels. That's no. Label is the actual answer. To train a model, you need features and labels to train, but to test it, you only need features. So the first one is definitely out. What about the B? Randomly split the data into rows for training and rows for eval. We're taking rows means we're taking both training and label columns. Next, use label for training, feature for evaluation. That kind of makes sense because label means you are giving the algorithm the answers plus the actual data, and you are then using only the data to test whether the model does a good job. Okay. Now, what would be a better answer would be randomly split the data into columns for training and columns for evaluation. Does that make sense? Because remember, in a table, I would have patient data, for example, patient data item 1, patient data column 2, patient data column 3, and here is the patient medical diagnosis. Patient medical diagnosis. When I'm training the model, when I'm training the model, I'm going to need only, let's say, for training the model, I only need all 4 of them when I train the model, okay? But when I'm testing the model, I just need 1, 2, 3. All right, I only need this 3. So you can see for training, I need all 4. For evaluation, I just need only the last 3. So you can see that I need to split this at the column level, all right? Okay, so I think to some extent, the answer here would be to split data into columns for training and columns for evaluation. Some columns are not meant for eval because they contain the label, they contain the answer, okay? Now, if I do that, it says randomly split the column. So I cannot randomly split. I only got to choose the labels and the features. So I think the correct answer in this case would most probably be B. All right, B will be the correct answer. We're going to take a bunch of rows and say this is only meant for training, and a bunch of rows which is only meant for eval. In the eval, you're going to exclude one column, not a random column, one specific column, which is the answer. Okay, so in this case, the answer will be B. All right, let's go on. Take a look at question 8. In question 8, it says you plan to deploy an Azure machine. Again, Azure machine learning is where you go to deploy the end-to-end of a model, from data all the way down to a model that's evaluated and trained and deployed. Okay. Now, you plan to deploy an Azure machine learning model as a service that will be used by a client application. So which 3 processes should you perform in sequence, all right, before you deploy the model? Now, let's see if I can kind of draw this on a whiteboard for you. Maybe it'd be interesting. Let me just get my whiteboard out. I'm going to bring this over to the screen share that I have, and let's take a look at that. All right. Okay, here. So we're going to start off with the data that we have. So this is our source data, right? So we most probably will have to perform some sort of transformation of the data, and we're going to then pass the data over to, let's see, I'm going to need to have this arrow here. That's interesting. Okay, an object was added. We can't display this version of whiteboard. That's very interesting. Okay, no problem. I'm just going to use this arrow here. Makes sense. And then we're going to give it to a machine learning algorithm. Okay. Now you notice this data that you have over here, we need to split it, right? We need to split 2 parts to it. We need to split it into training data. So this data we're going to use for training, And we're going to then have another set of data that we're going to use for evaluation. The evaluation data is going to go from here all the way down to the part where we already have the model working. So here is going to be evaluate. Okay? Evaluate, that's correct spelling. Okay, so once you've given this to a machine learning algorithm, what the machine learning algorithm is going to do is going to generate a machine learning model, which is what I mentioned earlier, machine learning model, which is nothing more than a code algorithm, okay? Algorithm, correct? And if it's related to a human cognitive services, you can say it's a AI model, okay? Now, because you have generated this AI model already, one of the things that you're going to do is you're going to bring this eval data, you're going to pass it to this model, and you're going to see what is the outcome. So this is the measurement of it. So here you would get a measurement accuracy. Let's say, just for discussion purposes, let's say this is accuracy measurement. Okay? So now looking at this diagram here, can you tell me, looking at this diagram, can you tell me what will be the sequence of work? Maybe I can show you that again. Training, pass it to the algorithm, you get your model, and then you do an evaluation using the part of the data. Okay? So in this case, what is the sequence, right? First, we need to do a data prep. Definitely, we need to do data prep. So this data that you have here, let's just put the word data here. Before that data becomes available for any one of this, they need to be prepped. One of the prep is to split the data. Another one of that prep will be to prepare the data, like transform it, change certain information about the data. Like, for example, we have this categories of data. It's not very nice for the algorithm. It doesn't like it. So you need to flatten it. So we need to do that stuff, what we call feature engineering, okay? So first thing we need to do is prepare the data. So I would say prepare the data will be the first one. This is number one. Let me just write it here. This is one, okay? Once you've done that already, remember we only need 3, okay? We're going to then do a training. This is where we pass the data to a machine learning algorithm, which then generates a machine learning model. Once you've done that already, the third process is to evaluate the model. Is the model good enough for us? Why? The way we evaluate is by using this evaluation data, right? And we pass it to this model that we generated, and we try to see what is the outcome that's generated. Okay? Everyone understand this question? I'm trying to look at, can we have this practice for AI-102? I would love to do that. Okay. Now, let me just give you a little bit more details on this. Imagine you have patient data. This is patient data. What kind of patient data you would have? Well, anything from the weight to blood measurement, blood works to et cetera, correct? This is example. Now, you also have patient diagnosis. The doctor has already done the diagnosis of this, and that will be things like it has diabetes, is diabetic, correct? Example. So if you take a look at, there's 2 kinds of data in this state. One is what we call the patient data. We call this the feature, and this is the label. The label is actually the answer. So when we do training, we will need both of this. When we do training, we need to present both of this for training, okay? But when we do evaluation, we only need to present this part. Why? Because we are going to give this data and we'll see what did the machine learning model predict, and we'll then compare with this one. What's the prediction this? If this is the real one, this is the real prediction, and we'll see what they predicted. Then we can compare that and see how many times did it give the wrong answer, how many times did it give the right answer. Okay, cool. That is that discussion. All right, hope that just gives you a very good understanding of how that is. Okay, let's go on to take a look at question 9. Match the machine learning task to appropriate scenarios. To answer, drag the appropriate task from the column on the left to the scenario on the right. All right, so it looks like we need to do for all of them. Okay, so you can see there's only 3 answers. There's only 3 answers I have to give, but I have 5 options: 1, 2, 3, 4, 5. So you only need to use 3 of this, and you can use it multiple times. Usually this question, they allow you, see, it says here that you can use it more than once or not at all. So for example, you can use feature engineering here and here, or you completely avoid this one. Okay, based on the drawing that I had for you, I think it's a pretty good drawing. Can you tell me what the answer is going to be like? Now, remember, you will need to prepare the data. So I'm going to do something for you here, correct? I'm going to do a couple of things. Number one, we need to prepare data, correct? We need to, example, prepare data. We use the word called feature engineering, correct? And number two, we'll do one more thing known as, let me see, I need more space. So I need to have more space. I'm going to move this a little bit here. I'm going to move this here, and I'm going to move this all the way here and say here. All right, perfect. I think this is good enough. Okay, good. So we're going to do prepare data. Example, another thing that we might do is split data, correct? Number one. Number three, we might do is transform data. Okay, transform data. We might do things like this. A feature engineering. Now, again, what is feature? I'm just going to write it down here. This is what we call a feature, aka the question, and this is what we call a label. Now, some machine learning algorithms, they are very sensitive to the kind of data that you have. So you need to prepare the data. You need to prepare the features, right? I give you an example. If you have a data where you have a measurement of a shirt size, so you have XL, L, small, and medium, and so on and so forth. Then you have shirts which are color blue, red, white, green. Now, typically in a table that we store data, we just write one column, shirt size, and that column will have different values, right? XL, L, M, or so on and so forth. But what you need to do when you're working with a machine learning algorithm, you need to flatten that. Means that instead of just one column which says size, and then it could be anything XL, ML, or small, you need to now create 6 columns for every one of those measurements. So if a shirt was small, you would put 0 for XL, 0 for large, 0 for medium, and then you'll put 1 for small. So you need to show all that. So we need to do that, and that's what feature engineering is. It's just one of the things about feature engineering, okay? So let's go back here. Look at my diagram, what I've drawn, and let's go back and try to see what this question is all about. Okay, so what to match the machine learning task to the appropriate scenario. So number one, examine the values of confusion metrics. Confusion metric is not this Chinese bearded stoic person. That's different. That's Confucius. This is confusion. All right, so examine the values of confusion metrics. Number two, and you do that, when do you do that? Then splitting a date into month, day, and year fields. Hey, that looks like the idea I just mentioned earlier, right? And what about the last one? Picking temperature and pressure to train a weather model. What would you do? The first one would be examine the value will be the evaluation part. Looks like that is something that you do at the end. I'm going to go here and choose this pen. And, oops, sorry, here. What happened to my pen? Let's grab the pen again. Here you are. So this is the evaluation part. All right. You are evaluating the model. You look at the metrics and you see how good the model is doing. Next one, splitting a date. So this is the splitting the date, right? Splitting the date into month, day, and year. So splitting a date means you are doing feature engineering. Okay. Out of all the features, you may select only some that you need to use for training, and that would be feature selection. I think this is what it is. Okay. This is picking up temperature and pressure to train a weather model. So I think this is the answer. I mean, it could be the green one as well. Oops, sorry. It could be this too, but I don't think so. This is the correct answer. The best possible answer is that. Let's go back to this diagram again. Can you see here? I have many features. I have weight, blood works, blah, 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 whatever. Maybe I only want to pick a few things out of all the features to be trained. I don't want to use the others. I can do that, not a problem. Same thing goes with I'm splitting the data because I want to do training and I want to evaluate. Okay. And then once you have already got a model done, you're going to bring evaluation data, pass it to this model and see what the outcome looks like. The way you measure is you need to look at metrics. And one of the metrics that you can look at is the confusion metrics. Okay. Cool. Let's go to number 10. Right. Number 10 would be the ability to extract subtotals and totals from a receipt. It's a capability of. Okay, so this uses an older name of a AI service that Microsoft now uses a different name. The name is called in document intelligence. The previous name of this service is called the form recognizer. So the form recognizer is the one that we use to be able to extract fields and values from an example, a receipt. A receipt is considered to be a pre-built model that you can use. If you have a custom form, you most probably have to train the model to be able to do that. But this is definitely something that goes straight into form recognizer. Remember, the new name for form recognizer is document intelligence. Okay, cool. Then let's go into a couple of last few questions. Let's go to question 11. You are building a tool that will process images from retail store and identify the products or competitor. So you're looking at images from different retail stores, not your store, but retail stores, and see at any point of time if there's a product which belongs to the competitor. So it looks like images. So the key word here is images. Correct? The solution will use a custom model. So I think it's definitely going to be a custom vision, because the model by default doesn't know who's your competitor. It doesn't know. It just knows, yeah, this is a brand, but it doesn't know it's a competitor to you. So what you need to do is customize that vision AI. Okay. So it has to be custom vision. So what you'll do is you'll provide an image of all your competitors to their custom vision and train the model to recognize those competitor images. Then you go into a retail store and take a picture, and it will look at the picture and say, oh yeah, that one is a competitor of you. That's what it's trying to do. All right. Pretty good question, this one. Let's take a look at this one here. This is interesting, right? You have predicted versus true chart shown in the following exhibit, right? Which type of model is the chart used to evaluate? Which type of model? So that these are just different types of model because they use different algorithms: classification, regression, and clustering. Correct? So anyone want to give it a shot on what this answer should be? Clustering is something that we use for unsupervised learning, all right? And regression and classification will be either 1, 0, yes, no kind of classification. Like, tell me whether a person's going to buy or not going to buy. Regression will be a value. Tell me how much sales am I going to make? Give me the number. It will then give you a number, right? Okay. So you can see right here, I have a true value. It's no longer about classification. Correct? I'm not classifying it whether you won or no, yes or no. So this is more on a value, right? So this will be an example of a regression. Okay, you can see the measurement of this is the predicted value, right? And you can see that what the value changes. Okay, so of course, maybe due to the parameters, the value is changing. All right. So you can see it's pretty close to what the average predicted value and what the ideal is supposed to be. So the keyword, you can look at that and shows you what the value is. If it's classification, it wouldn't be a value. It'll just be a yes and no. Okay, there's no such thing as evaluation of a value. And clustering, definitely not clustering, because this looks like something that is used for supervised learning, where you know what the when you train it, you know what the label was, you know what the feature was. Okay, pretty good example of that. I want to show you something here just to give you an idea about how this tool look like here. So it gives you an idea of how this tool will look like. A classification will look something like this. Remember, a classification is either 1 or 0. So it's either here or either here, either yes or no. If like Spotify classification, we're going to recommend this music, or we're going to recommend the other one, or whether you're going to buy as a customer or you're not going to buy, or you have a disease or you don't have. This is regression. It'll be a straight line like that. All right. Okay. Cool. That is that answer. Finally, question 13. At the moment, let me see how much time do I have left. I think we have about 1 minute more, I think. I think so. Let me see. Hold on. Okay, finishing up. Yeah, let's go to the last lucky question 13. What type of machine learning should you use to predict the number of gift cards that will be sold? Look, again, it's a value. If I say predict whether cards will be sold or not, that would be classification. But because that's a number, we will not to know how many gift cards will be sold. So that is definitely going to be regression, because that's a value that's being predicted. All right. Cool. Now, I do have some additional question. Let me go to the last one and then we'll wrap it up. Okay, you are building an AI-based application. You need to ensure that you follow the principle of responsible AI. Which two principles should you follow? Each correct answer will represent a part of the solution. Okay, only three choices. Now, number one, implement a process of AI model validation as part of software review. Now, this is nothing to do with principle. I think this is just software quality checking, so it's not responsible AI. Okay, number two, so we need to select two principles. All right, what about if this is wrong? Definitely B and C. Okay, so let's take a look at B. Establish a risk governance committee that includes a legal team, members of risk management. Yep, I think if you're going to run an AI model, you most probably need to know what is the parameters of the risk that will be created by the model. For example, the self-driving car might crash the car, so there's a risk. So you need to then think about how you mitigate that risk. Number three, prevent the disclosure of use of AI-based algorithm for automated decision making. Right? Prevent the disclosure of the use of. Oh, I think this would be wrong too. So between this and this, seems like this is even worse. Prevent the disclosure of use of AI-based algorithms. So you got to let people know this is definitely transparency. So this definitely is not following it. So I think I will go with A and B. So even though you implement a process for model validation, Mimis want to find the accuracy, even though it's software related to see the quality of code. But I think these two are what we're going to do. So answer should be A and B. All right, so I think I'm done with the question in the time that I'm allocated. So thank you very much in all the different languages, depending on where you are from and what language you speak. Here's a little bit, here's my contact details if you do have additional questions, and my LinkedIn and my email, correct? I think I'm done. Let's call Suzanne back in again.
Hi, Sab. Thank you so much.
No problem.
That was very helpful questions and tips. I'm sure everyone watching this feels a little more confident and a step closer to getting that certification.
Awesome.
I mean, we already have Samya asking for AI-100 102. Definitely looking forward to doing more of these certification prep sessions.
Okay, sounds good. I'd love to do that.
Yeah, so thank you so much for joining us up.
Okay, thank you very much, everyone. Have a good day.
Right. So moving on, thank you so much for being with us. But learning doesn't end here, or this session itself. So be sure to click on the resources that Sub has shared. So it's also available in your YouTube description below. So if you do have some time to work on this certification and our season 1 episodes, I'm just going to quickly share it here. Feel free to watch them, catch up on them. We have also released our first episode of season 2 online actually. So you can find them in aka.ms Startup AI School. Yeah. So I'm gonna hit on the ticker so you can bookmark the link. Okay, great. So yeah, the upcoming episode will be about AI and industry transformation. So check that out. And sharing some upcoming community events as well. While we take a break on Startup AI School, right? We do have community events coming up. It's actually for the community, by the community itself. So check it out. So we do have topics on like DevOps, GitHub, etc. So the upcoming one is actually in Malaysia. But if you can't join us in person, Microsoft Reactor is bringing it to your home or to where you are based. So you can actually join us on online. It's a hybrid version of the event. So yeah, let me see. What else do we have? Right. So to you that's watching this session today, if you found it helpful, please hit on the like and subscribe button or notify so that we will notify you of new shows that comes in. And don't forget to leave comments on the content you'd like to see. Yeah, I mean, it's always good to know what you're looking for so that we can do more beyond today's live stream. So yeah, thank you so much for joining us today. We hope you had fun, and we'll see you in our season 2 once again. Thank you.